Good day. We're going to do notes today on dilution. I believe this is day 3 of our notes. I'm going to do dilution and solution stoichiometry. Dilution is decreasing the concentration of a solution by adding more solvent. You can see from these pictures you're going from a more intense color to a less intense color. So that's from concentrated to less concentrated. That's called dilution. Chemists spend time diluting stock solutions of acids when preparing for labs. Stock solutions of acids, sulfuric acid is 18 molar, holy moly strong. Nitric acid is 16 molar strong, enough to melt your nose hairs. And hydrochloric acid is 12 molar. That's also enough to make you choke and gag if you inhale the fumes. And there is a bottle of what nitric acid looks like. Must be very, very careful with these glass bottles. If they break, you're in trouble. When diluting, don't delude yourself. Note, the number of moles before diluting are the same as the number of moles after diluting. Only the ratio to solvent or concentration of moles changes. The actual moles are the same before and after. If a solution is diluted, the molarity decreases. That means you get a smaller number. The key to doing these problems is that only water is added to dilute a stock solution. It's like diluting grape Kool-Aid because you thought it was too grapey. You wanted it half as grapey. These are before and after problems. I think you're going to recognize the equation, although the variables are a little different. So the dilution formula, M1V1, M2V2, molarity 1 times volume 1 is the same as molarity 2 times volume 2. That means the moles are the same before as they were after. Just the volume changes, which changes the molarity. So molarity 1 is before, molarity 2 is after, volume 1 is before dilution, volume 2 is the total volume of solution after dilution. Let's do a dilution practice. This is number 1A on worksheet 4. It says calculate the new molarity that results when 250 milliliters of water is added to 125 milliliters of 0.251 molar HCl. What do we know? That's what you always ask yourself. What do I know? I know that molarity 1 is 0.251, and I love to write out moles per liter. It makes me so happy. Oh, and that was the HCl, HCl. Then we have volume 1 is 125 milliliters. If you want to change that, you can to liters. Probably should, because this is all in liters. 100.125 liters. Move the decimal over 3 times to the left. Lefty-loosey, righty-tighty. Volume 2, trickery-dickery-dock, 0.125 liters. I got that from the V1 plus the 250 milliliters we're going to add, and we're going to call that 0.250, all those zeros. Liter is 0.375 liters. And what is it we're trying to find? We're trying to find molarity 2 equals what? And that's going to be in moles per liter. I think we're going to bust out an M1V1 is M2V2. That's the first thing. We got that equation, and we need to find M2. If you do some algebra, college professors love to see your algebra, M2 is going to be M1V1 divided by V2. A little rearranging. And then if we plug and chug, 0.251 moles per liter times 0.125 liters, and we're going to divide it by volume 2, which we added up to be 0.375 liters. Multiply, multiply, divide, and you get bada bing, ka-chung, 0.0837, and you go big M molar, put a lovely geometric shape around it. Ha! Zabadida. 0.0837 molar. I love it. And was the molarity less? By golly, by gum, it decreased because we diluted it. And that's what you'd expect. Solution stoichiometry. Stoichiometry keeps coming back to get you. Balance your equation. Find the moles, grams to moles, or you may need to do molarity times volume to find moles. Find the limiting reactant if necessary. Oh no! Mole ratio from the given, go from the given to what you want. And then you need to find the grams, either go moles to grams or You may have to find volume, which is going to be moles divided by molarity, or you may need to find molarity, which is moles divided by volume, or the thing that you want. Let's do an example. This is on worksheet number 4, and this is question number 4. How many grams of PbI2 are formed when 500 milliliters of 0.550 molar Ki reacts with excess lead nitrate? So we got some good verbiage going on here. I think we need a color up change. Let's do that. So we know, if we look at this, that one's the, hello pen, the excess. So that means no worry about you. And then we're going to move on to the Ki. What do we know about Ki? We know we have 500 milliliters, 500 milliliters of that, and that equals a half of a liter. Always go to liters, you never know. So we have, there we go, a dot. We have that, and what else do we have? We have 0.550, and I don't like to write molarity, I like to write moles per liter because it spurs something in your brain. So we know that about Ki, and the thing we're trying to find, the one that we want, is PbI2. We want this one. So what is that, and what is it we're trying to find about that? How many grams? Okay, so we're trying to get to grams. So we're going from Ki to PbI2. We've got to balance the equation. If you don't balance your equation, you may get this wrong. I believe we need to put a 2 there. Look at that 2. Give me a 2. Give me a 2. And we need a 2 here. So that will affect how we do this. Let's go back and start. So I think the first thing we're going to do is we're going to go molarity times volume to give us moles. Because we know the molarity right here, and we know the volume. Haha. So we're going to go 0.550 moles per liter times a half of a liter. And what do we get? Go on the calculator. 0.275 moles of Ki. Yes. So now that we have moles, finish your I. There we go. We can do some stoichiometry, which means we're going to take the 0.275 moles of Ki, and we're going to do the mole ratio. So we know we have 2 moles of Ki to 1 mole of PbI2. I just got those numbers from the coefficients. And we could actually add one more step on this because it wants us to go to grams. We know that 1 mole of PbI2, sometimes you want to stop at that mole step and reevaluate what you're doing. 1 mole of PbI2 is how many grams? Oh, lead is heavy. I think that's why they call it a heavy metal. 461 grams of PbI2. I added up the P and the 2 I's. The I's kind of heavy too. And now we go 0.275 divided by 2 times the 461, and we get 63.4 grams of PbI2. Aha, that's how many grams we should get when we do that reaction. Sweet. That's beautiful. Stoichiometry is beautiful. And your homework is worksheet number 4, and it's 1 through 7. Have fun. Stoich out.